Hello guys, very good evening everyone. Welcome to the session and welcome once again to the Isro PYQ series. So yes, we all know that Isro has announced the recruitment for the post of Scientist C for year 2023. Okay, and yes, we are discussing up important PYQs, okay, of the Isro, okay, asked in the previous years. Reason being, how it can be important in two different ways. Number one, of course, it's going to be a practice session, no doubt, and also it will give you a complete level idea, right? That yes, how the level in Isro, what preparation you have to match, whether with respect to the Isro examination, with respect to the Isro previous examinations, right? Okay, good evening. Chalo, let's get started, guys. Let us get started with the digital electronics. For electrical, because this recruitment is for electrical, for electronics and computer science we'll be expecting in the upcoming time. Right now it is for electrical and civil majorly. Okay, but yes, for electrical, like I've taken some sessions on the control system also few days back. So control system, you expect good number of questions. Digital electronics also questions keep coming for electrical, but the level is really moderate, easy to moderate, okay, for electrical students with respect to digital, and that's what I'll show you in this session. Okay, so let's get started, guys. Yeah, and before we start up, an very important update for all of you, that all your favorite dashing Joshit Singh sir, he's going to come live this Sunday, just in 2 days, at 12:30 p.m. on the BYJU'S exam prep app, and he is going to conduct a free, very important mega workshop on the detailed strategy to secure rank under 100, to secure a rank under 100 in the upcoming GATE 2024 examination, right? Strategy. Okay. See, both are good. That it depends, what eventually which field you want to work into it. Okay, if you become an ESE officer, the work there will be technical plus managerial. If you work at Isro, it's going to be pure technical and a scientist based work, research based work it is going to be. So it depends, what your priority is. Both are good in their own sense. Okay, Datta. Chale guys, and one more important update, that on the YouTube, right, on the same channel where you are watching this session, I bring to you again a very important strategy session. Yes, if you want to secure single digit rank in GATE but are confused ki what are the guidance, what are the steps, whether you are on the correct path or whether you are not on the correct path, okay, I am going to take a session where I'll talk about the five important, very important success mantras, okay, to secure the single digit rank in the GATE examination, so that following this 1, 2, 3, 4 and 5 steps, you ensure your victory. Okay, and this is going to be happening on the YouTube this particular Sunday at 11 a.m. this particular Sunday at 11 a.m. Done hai ji? Theek hai. Let's move ahead and let's get started, guys, with this first question here on your screen. What is the octal equivalent of the hexadecimal number? A very fundamental question that is asked in Isro 2018. The Isro 2018, right? Chalo, come on. What is the octal equivalent of the hexadecimal number CD.AB? Okay. CD.AB. CD.AB. Okay, what is C? Now, what is the process C? The process from hexadecimal to octal directly is using the binary number system. Okay, because octal is like base 8, hexa is base 16, and both are of the form 2 power n, and whenever there is a number in the base 2 power n, it is easy to convert into binary or vice versa. So I can convert it into binary. Now hexadecimal is 2 power 4. Hexadecimal is 2 power 4. So what do we do to convert hexa into binary is write down every hexa digit into its 4-bit binary equivalent. Like C is 12, which is 1100. Of course, it is expected that normally up to 15, 16, at least up to 15, 16, you directly remember the binary conversions, and which you remember with slide practice only. Right? D, just after D, that is 13, 1101. Okay, then dot, the decimal point. A is 10, 1010, and then B we have, that is the 11, and that is 1011. Now we need to convert this back to octal, and octal is having the base 8, that is 2 raised to the power 3. Okay, now to convert binary to octal, you will be grouping that binary number into groups of 3. Octal has the base 2 power 3. So now you are going to make the groups of 3. Okay, starting from where? Starting from this point. Yahan se start karo. Okay, and go to the left and to the right respectively. Okay, so if I go to the right, 1 0 1 0 1 0. Now 1 1. I want to make groups of 3. What will I do here, sir? Add any number of zeros at the end of a number. After decimal point, it doesn't matter. Now, whether suppose if I take decimal example, whether I give you a number 99.2 or whether I give you a number 99.20 or whether I give you the number 99.200, is there any difference in the magnitude? No, no. So what I can do is I can add up a 0 here. Now similarly, I want to go to the left. I'll start making groups of 3. This is 3. This is 3. Again, I am left with 2. Okay, so what do I do? So similarly, as I'm telling you 99, or whether I write down 099, it is also 99. So you can add up any number of zeros, preceding in the beginning. That doesn't affect the value of the number. So I added a 0 here. Now convert every 3-bit group into octal. So 0 1 is 3, 0 0 1 is 1, 1 0 1 is known as 5, 1 0 1 is known as 5, 0 1 0 is 2, and 1 0 0 is 6. So answer should be 315.526. Answer is D. 315.526. Correct answer is D for this question. Moving ahead to the next question. Ready for us. What is the 2's complement of the binary number 001001101110011101? Now we know how to calculate 2's complement. There is a catch in the question, but there is a small catch in the question. And what is that catch? If you have a look into the number, if you especially have a look into the MSB of the number, MSB of the number is 0, representing positive number. Now, what is the 2's complement representation of positive number? Do you take the 2's complement of positive number? If you start taking 2's complement for positive number also, then there would not be any difference between a positive and negative number. This is a positive number which is always stored in the direct binary form. For it, we don't need any 2's complement. So even if I ask what is the 2's complement representation of this number, it has to be the same. 0010110111011101, right? So that is not there. Okay, that is not there. Okay, that is not there. Now that means so conceptually it goes wrong, conceptually it is wrong, but yeah, then you can take 2's. Actually the concept I've told you is for positive number we never take 2's complement. 2's complement is taken only for negative numbers. Okay, so here they have not given any particular decimal number like 110 yeah minus 110, 200 yeah minus 200. They have not specified. So what they expect from you is given a binary number, do you know how to calculate 2's complement? Yes, we know how to calculate 2's complement. Okay, so calculate it immediately. Calculate this immediately. Okay, so if I know how to calculate, so that is what is the catch in the question I told you. So 0010, 0110, 1001, 1101. Now to take 2's complement, first I take the 1's complement. The simple method is first take the 1's complement, and to take the 1's complement we invert every bit. Okay, so 1101, just invert every bit. Okay, 10 0 1 0 1 1 0 and 0 0 1 0, and then at the last add 1 to the rightmost bit, whatever is the rightmost bit. Okay, so this will become 1 0 plus 1, then 1 0 0. Now see 1101, okay, 1001, 0110 and 0011. It is matching up as D. It is being matching up as D. The correct answer is D. Okay, that is the correct answer for the 2's complement. That one is the correct answer for the 2's complement, right? Moving ahead to the next question. 0 has 2 representations in which number system? 0 has 2 representation. It has 2 representation in sign magnitude as well as 1's complement. So this is a ISRO 2018 question, but it will have 2 answers actually. Okay, it will have 2 answers. It cannot have 1 answer. Okay, so maybe they give marks because in ISRO you can't challenge question also like GATE, or maybe they give marks if you select any one of them. Some questions come up wrong in government exams, so you can't help it out. Okay, the question is not wrong means both the options are correct. 0 has 2 representations. Okay, if you take a 4-bit example, I can explain you. If you take a 4-bit example, so 0, if I talk about the magnitude, it is 0 0 0 0. Okay, but now let me explain you that if I want to represent sign number in sign magnitude system, in sign magnitude system. Okay, in sign magnitude system, what is plus 0? So in sign magnitude, one bit is for sign. The first bit is of sign and 0 means MSB. Only the next 3 bits are for magnitude, right? So even if you want to write down in 3 bits, 0 will be 000, right? What is minus 0? The first bit is sign and for minus number it is 1 and then we have 000. So this is how plus 0 and minus 0 are different. Actually, they should not be different. For human beings, they are same, but for machine, they are different. Okay, that is one of the drawbacks also of sign magnitude. And similarly, this is the drawback of ones complement machine also. Right. What is plus 0? Plus 0 is same. As I told you, for positive number, just now what I told you, for positive number, we don't take any complement. Okay. But for negative number, we should take the complement, and I'm talking about ones complement system. So when you take the complement 1, 1, 1, 1, it is totally different. It is totally different. But on the other hand, when you talk about a 2's complement machine, right, what is plus 0? Plus 0 is 0, 0, 0, 0. But what is minus 0? Minus 0 will be stored by taking complement. We take complement for negative numbers, and to take 2's complement, first we take 1's complement and then add 1. And then add 1. So 1 plus 1, 0, carry 1. 1 plus 1 is 0, carry 1. 1 plus 1, 0, again carry 1. 1 plus 1 is 0, again carry 1. But that carries the 5th bit, that is discarded. Okay, so this is what is your answer. The 5th bit cannot be stored because I have taken a 4-bit example. So what is your answer? 0, 0, 0, 0, which is same as plus 0. So that is what we want. Even human beings know plus 0 and minus 0 is same. There is no, sign for 0, and that same system is followed in 2's complement machine. That is one of the reasons of, the 2's complement machine being so popular, but not the sign magnitude and 1's complement. But answer for the question will be both A and B. Moving ahead to the next question. What is the output of the XOR gate with A and B as the input? So guys, you all know it's a very fundamental question. Okay, that when you want to talk about the XOR gate, we all know what is A XOR B. It is A bar B plus A B bar. It produces a high output when both the bits are different. So 0 1 and 1 0. 0 1 is coded as A bar B and 1 0 is coded as A B bar. Okay, but there is one more way of writing A XOR B. That is the complement of XNOR. That is the complement of XNOR. That is the complement of XNOR. So what is the complement of XNOR? Achha, what is XNOR? XNOR is A bar B bar plus AB. XNOR means the output is high when both the bits are same. Equivalence gate hota hai wo. That is 0 0 or 1 1. Okay. The complement of this is XOR because XOR and XNOR are complement of each other. Okay. So when I apply the De Morgan's law, okay, A bar B bar will become A plus B. Plus will become into, and A into B will become A bar plus B bar. These are the two ways of writing the XOR. These are the two ways of writing the XOR. Okay, the first one is known as the SOP expression, sum of product. The next one is known as the POS expression. So these are the two ways of writing the XOR. Okay, so definitely AB whole bar plus AB, that is wrong. Okay, can this be right? ये तो totally wrong हो गया. Can this be right? A plus B whole bar. That is A bar B bar into A plus B. And when you open the bracket, first term A bar into A multiplied 0. Second B bar into B is 0. The total answer itself will be 0. ठीक है. Next, A plus B into AB whole bar will become A plus B into AB whole bar by the De Morgan's law. It is A bar plus B bar. हो गया ना ये? That is what is your form. Okay, so C is the correct answer. C is the correct answer. D is again wrong because when you open A plus B whole bar, it is A bar B bar plus AB. That is XNOR. That is XNOR. Correct. So correct answer is C. Okay. The fundamental simple question this is. Next question. ISRO 2020. Okay, NAND and NOR. Okay, commutative or associative, that is what they want to check. What is a commutative operation? In which operands can be interchanged. Okay, operands can be interchanged. So if I want to talk about NAND, right, A into B, right, whole bar, it is a NAND representation. A into B whole bar, is it same as B into A whole bar? Yes. If I want to talk about NOR, A plus B whole bar, that is NOR, will it be equal to B plus A whole bar? Yes, because A plus B is B plus A. right? So both are commutative. Both are commutative. There is no doubt in that. Commutative? Yes, commutative. Whether they are associative. What is associative? Like addition is associative. Okay, like A plus B plus C. If you want to add three numbers, what you can do? Maybe you can add B plus C and then add A, or maybe you can do A plus B and then add C. Right? Both are okay. Now, that is what is addition. That is what is simple addition, and which is associative. And not only addition, you can even take the example of multiplication. You can even take the example of multiplication, right? Now, what about the NAND or the NOR? Okay, so A into B into C. Okay, so let me first take BC. Okay, and in one of the case, I will first take A into B and then I will take C. Okay, are these two operations same in terms of NAND? Okay, in terms of NAND, that first you take the NAND of BC, okay, and then you are going to take the NAND with A. Okay, then here first you take the NAND of AB and then you take the NAND with C. Okay, first BC or first AB. So if you open this, now what is this? Okay, this is going to be A bar plus this is BC whole bar, that will become BC. What is this? This is going to be AB plus C bar. Is it the same? Not at all. Is it the same? Not at all. So NAND is not associative. It is not associative. NOR की बात करें तो, okay, NOR की बात करें तो, okay, so similarly I'll try again with A plus B. Okay, यहाँ पे पहले BC लिया था, तो let's take BC only. A plus B plus C. First I take the NOR of B and C and then I take the whole NOR with A, right? Is it equal to A plus B NOR then NOR with C? Is it equal? Is it equal? So let us take, that will become A bar into B plus C. Then right side it should be A plus B then into C bar. The basic Boolean laws I am enjoying, the De Morgan's law. So this is A bar B plus A bar C. This is equal to AC bar plus BC bar. Are they matching up? No, not matching up. Not matching up. Not matching up. So both of them are not associative. Okay, both of them are not associative. So what is the correct answer? Okay, so if you have studied, all these points with gates, so this is what results, standard results you must already be knowing. Okay, so both are commutative, option number D, but not associative. Both are commutative but not associative. Okay. Next question, the truth table represents what Boolean function? The given truth table represents what Boolean function? The given truth table represents what Boolean function? Very simple question. Huh? Okay, the function is high at the 1, 0 and 1, 1. Right, so what is that function? 1, 0 will represent x into y bar because x is 1, y 0, so we take the complement. When the variable is 1, take it directly. When it is 0, take the complement. And next, also it is high at 1, 1, that is xy. So in this x is common. You are left with y bar plus y, which is equal to 1. So f is simply equal to the x. F is simply equal to what? F is simply equal to the x. F is simply equal to the x. Done? What is happening? Done. Very simple question. Next one is from 2019. What is the simplified Boolean equation of the logic circuit if the circuit output is 1 for the following inputs? If the circuit output is 1 for the following inputs. Okay, for the following inputs. So you are first going to construct. Okay, you are going to first construct what? Okay, it is in 3 variables. See, not necessary to construct K-map. Okay. Yeah, as a practice, it is definitely useful for EC. Right now, Isro has not announced EC recruitment, but it is likely to announce the recruitment for EC in the near future. Or otherwise, it is generally a practice session for EC because digital is important for EC in other competitive exams. Okay, so you can definitely take some practice from here, Pinky. Okay, so देखो, there is one way that is K map. Okay, or there is another way, you can directly pick up Boolean. And since there are only 4 terms, okay, I can directly pick up with Boolean as well, and they are also differing. Like if I see the first 2 combination, there is only 1 bit difference, so we can directly combine them. Na? Whenever 2 combinations differ in 1 bit, they will always reduce a variable. 0 0 1 0 to A bar B bar C D bar plus what is the next term? 0 1 1 0 to A bar B C D bar. Next one, again these 2 differ in only 1 bit. Sorry, these 2 also differ in 1 bit. तो 1 0 0 0 तो A B bar C bar D bar, ये प्लस करते जाते हैं, प्लस लास्ट इज A B C bar D bar 1 1 0 0. Okay, what is the combined result of first 2? The first 2 mein guys, A bar C D bar is common. B bar plus B, no need to write. B bar plus B is equal to 1. Okay, B bar please is equal to 1. First 2 mein guys, A bar C D bar is... Na Jay Kumar, voice is okay, I think. Voice is okay, just refresh it once. Next 2 पे आ जाएंगे, तो again next 2 में what is common is A C bar D bar. A C bar D bar, again B bar plus B, that is equal to 1. Okay, so now your answer should be, can I take any particular thing common from here? No, they differ in A also, C also. Okay, so they differ in 2 bit. Okay, so here reduction will not be possible. ठीक है, so it is going to be A bar C D bar, A bar C D bar plus A C bar D bar. Option number A, directly matching up. Option number A, correct. Option number A, check it out guys. Pinky, exact date though we can't say, it is likely to be next 2-4 months, but nothing date and all we can say with surety. Chalo, moving ahead. How many numbers of half adders are required for m bit adders? Okay, for m bit adders you need m full adders. Very simple, you need m full adders, correct hai na? You need m full adders. Okay, and for m full adders what do you want? For m full adders, what do you want? Right. See, what is one full adder? One full adder is constructed using 2 half adders plus 1 external OR gate. Right. For m full adders, okay, every full adder has 2 half adders, so you will have of course 2m half adders plus m OR gates. M OR gates, so 2m half adders. Okay, now you know sometimes people will start putting the logic A is also correct because for the LSB we can take the half adder also, but this is not how usually the parallel adders are defined. This is not how usually parallel adders are defined. Okay, there are 2 ways, either you take m full adders, right, or there is one more way that you can take m minus 1 full adders plus 1 half adder directly for the first stage. 1 half adder for LSB stage, because we know that at the LSB there is not going to be any carry. But remember that even like suppose 4-bit adders can be cascaded, 2 4-bit adders can be cascaded to build a 8-bit adder, 2 8-bit adders can be cascaded to build a 16-bit adder, so their LSB also will have a carry, can have a carry. Okay, so we can't say that this is very specific case. Okay, this is the most general case. This is the most general case. Okay, so we'll go with the general answer, that is 2m. Okay, we will go with the general answer, that is known as the 2m. That is known as the 2m, right dear? Chalo, okay, so we'll go with the general answer. Very simple question, multiplexer, you will be able to solve it up. Come on, let me know the answer for this. Okay, the combinational logic circuit shown in the given figure has an output Q which is how much? It has an output Q which is equal to how much? Right, A, B, C, A plus B plus C, A XOR B XOR C, A into B plus C. What is that? Okay, what is that? Let's do it up quickly. And if the select line is 0, what is there at the select line? AB. The select line 0 means A bar B bar multiplied by I naught, which is C. Select line 0 1, that is A bar B into 1. Select line 1 0, that is A B bar into 1. Select line 1 1, that is AB again multiplied by the input line I3, which is 1. Right, because we know at 0 0 I naught is selected, at 0 1 I1, at 1 0 I2, at 1 1 I3. That is what is the pattern. That is what is the pattern. Okay, so yeah, the time to simplify this. Okay, so this is from the first two se start karenge. From the first I can take A bar common and then I am left with B bar C plus B, और vice versa लिख दे अगर B plus B bar C, and from the last two terms I take A common, B bar plus B equal to 1. Okay, so I have clubbed these two and I have clubbed these two. Okay, now guys, what is x plus x bar y? X plus x bar y, the complement goes away, it is only B plus C. Distributive theorem से derive होता है. Okay, so this becomes B plus C and then plus A. Then you can call it as A plus A bar B plus C. Okay, so you can write it like this: A plus A bar into B plus C. Again it is like x plus x bar y, x plus x bar y, so x bar, the complement goes away. Okay, so you are left with only A plus B plus C. A plus B plus C, that is the option number B. It is a 3-input OR gate actually, right? It is a 3-input OR gate. X plus x bar y, a variable, then its complement multiplied by y, the complement is omitted. The complement is omitted and the answer is x plus y. The answer as per this conditions is option number B. Option number B. Moving ahead to the next question. Again a fundamental question on Isro. Cascaded. 4 cross 1 mux cascaded with the 2 cross 1 mux. Yeah. Do it up quickly. Do it up quickly in a moment. Right. Just a minute. Yes guys, let's continue. Okay, so what is the answer if you have tried? Let's check it out. Okay, the 4 cross 1 mux is given to you. First let us calculate the output for this 4 cross 1 mux. Okay, the output for the 4 cross 1 mux, suppose that is equal to x. Iska output y hai, so let's call the output of first mux as x, and that is going to be select line 0 0. So that is A bar B bar multiplied by I naught, and what is at I naught is 0. Next is select line 0 1, A bar B, and then I1, which is 1. Next is select line A B bar, okay, that is 1 0, and then again it is 0. And next is select line 1 1, that is A B multiplied by the I3, but what goes at the I3? It is the select line A only. Okay, so what it is eventually, first is 0, then I am left with A bar B, then again next is 0, AB into A is AB, because A into A is A in the Boolean world, right? And now this is finally equal to, you take B common and A bar plus A will be 1. You take B common and A bar plus A equal to the 1. Okay. So the output of the first mux is equal to B, and now let us calculate the output of the second mux, Y. Okay. Select line here for the 2 cross 1 mux is C. Okay. So if C is 0, that is C bar, you select I naught, which is equal to X. If C is equal to 1, we write C, and then you select the I1, and which is coming from B. Put down the value of X, that is also B. So it is C bar B plus CB. Again you take B common, C bar plus C will be 1. So the answer is B only. Correct answer is D. Okay. Yes, Sandhya and Jai Kumar, the correct answer is D. The correct answer is D. Chalo, done hai. In a JK flip-flop, a fundamental factual question. In a JK flip-flop, race around condition occurs when? Race around condition occurs when? What is the condition? What is the race around condition for JK flip-flop? When both JK inputs are, ये typo error है, sorry. There is a typo error here clearly. I'll just correct that. Wait a second. When both are 1. That is race around possibility. When both are 1. Right. So that, because when both are 1, the flip-flop is in the toggle mode. Right. And level triggered. Okay, level triggered condition, the toggle keeps on occurring. Okay, the toggle keeps on occurring. If you leave the JK at 1, 1, okay, and if the clock is available continuously, it will keep on toggling. That is what race around would be. Next question. A mod 6 counter is realized using 3 numbers of flip-flop. The counter will skip how many counts? Okay, using 3 numbers of flip-flop, you can have 2 raised to the power 3, maximum 8 counts. So if you design a normal binary counter, if you design a normally binary up or down counter, it will count 8 states. But you have designed a mod 6 counter. Right? So how many counts will it skip? How many counts will it going to skip? It is going to skip 2 counts. Okay. It can actually count 8, but it is going to count 6. It is going to count 6. So it is going to skip 2 counts, right? Fundamental. See, even from the sequential circuit also you are expecting very basic questions in ISRO, not like gate level. Gate may have good questions from this particular topic, especially sequential. Okay, again there is a fundamental question. The output frequency of a decade counter. So we all know what a decade counter is. Which counts, decade is 10. Okay, so it's a mod 10 counter. Decade counter. It is a mod 10 counter. Okay, which can count from 0 to 9 or any consecutive 10 numbers, let's say. Okay, so it's a mod 10 counter. Okay, so output frequency. Now, commonly when we refer to output frequency, okay, we refer to the frequency of MSB bit. The output normally, without anything specified, conventionally we take it as the MSB. And frequency as MSB is known as the clock frequency divided by the modulus of the counter. Clock frequency, so it is clocked with 50 kilohertz, and its modulus is 10 because it's a decade counter. So the output frequency produced will be 5 kilohertz, because we know that counters are frequency division circuit. It's going to be option number C. Right? Yes, Sandhya Jay Kumar, is going to be option number C. Done. Chalo. Moving ahead to the next question. A 4-bit modulo 16 ripple counter uses JK flip-flop. Okay, uses JK flip-flop. If the propagation delay of each flip-flop is 50 nanoseconds, the maximum clock frequency that can be used is equal to how much? The maximum clock frequency that can be used is equal to how much? A 4-bit modulo 16 ripple counter uses JK flip-flop. Chalo. Let's work out on this. Okay, if the propagation delay, अब ripple counter है, okay, ripple counter है, propagation delay of each flip-flop, okay, is 50 nanoseconds. What is the propagation delay of a single flip-flop, T flip-flop? That is 50 nanoseconds. Okay, and 4-bit modulo 16, both have specified, but even if they say 4-bit, even if they say modulo 16, that is okay. What is the propagation delay? What is the total propagation delay, right, for a mod n ripple counter? For a mod n, for a n-bit ripple counter. Okay, if I want to specify in terms of bit, for a n-bit ripple counter, okay, what is the total propagation delay? It is n times t flip-flop. Remember this. If it was a n-bit synchronous counter, then what it is? Chalo, thoda sa quick review of the formula. Again, very fundamental and formula based question this is. So for a n-bit synchronous counter, it is TFF. because all the flip-flops will show the transition of states at the same time simultaneously. Okay, so that is why it will be, the total delay will be equal to delay of one single flip-flop, because all show the transition at same time. But here, okay, the transition starts from LSB. That is what ripple action is, one after the other, like wave, like a wave propagation. Here, okay, it is the clock that propagates from the LSB to the MSB one by one. So how many cycles are required? N cycles are required, one cycle per flip-flop. Okay, very briefly I am telling you because there is a practice revision session, not the detailed derivation session. Okay, but yeah, you can be able to recall these formulas. Okay, done. So right now what they are telling, it is a modulo 16 counter. Okay, it is a modulo 16 4-bit counter, right? So here what is going to be the total propagation delay? It is 4 times the T flip-flop, which is 50 nanosecond. So total 200 nanoseconds is the delay. Okay, required for one conversion, worst case. So what is the clock frequency that can be used? What is the maximum clock frequency? It is given by 1 upon this delay. Okay. Right. The time period of the clock should always be greater than equal to this TPD. Okay, that is why we say that the minimum time clock period is equal to TBT, and then the maximum clock frequency, because if time period is minimum, clock frequency is maximum, and that becomes 1 upon TPD. Okay, 1 upon TBT, and that becomes 1 upon T flip-flop for a ripple counter. Okay, so that becomes 1 upon how much we have obtained? 200 nanoseconds. 10 power minus 9. Answers are in the form of megahertz. So 10 power minus 9 goes above, and I write it as 10 power 3 into 10 power 6 divided by 200. 1000 divided by 200 is 5. 10 power 6 is mega, so my answer is 5 megahertz. So my answer is 5 megahertz. My answer is known as the 5 megahertz. Done ji? My answer is 5 megahertz. Sure. Chalo, done hai. Option number B. Option number B. Next one. What would be the maximum operating frequency of a mod 8 counter constructed with JK flip-flops having propagation delay of 8 nanosecond? Having propagation delay of 8 nanoseconds. Having the propagation delay of 8 nanoseconds. Now, here it's Isro 2020 with the ambiguity of a mod 8 counter. It's an ambiguous question. Intentionally I should take this so that, you know, I told you in the middle of the session also in government exams, okay, see gate maybe kabhi wo galat kar dete, but less chances, but here in government exams, you know, these ambiguities keep coming. Now mod 8, what type of mod 8 counter, whether it is synchronous or ripple, it's constructed using JK flip-flops, okay, but having propagation delay of 8 nanoseconds, that is also okay. What is the maximum operating frequency of such a counter? First of all, they want to talk about a mod 8. Okay, mod 8 requires how many flip-flop? 3 flip-flops. Okay, for mod 8 we require 3 flip-flops, right? So n is equal to 3. Okay. Now, if I assume a synchronous design, if I assume a synchronous counter case, okay, then clock frequency pucha hai na. So what is the F clock max? What is the maximum clock frequency? As I just told you, it is 1 upon TPD, and for synchronous 1 upon TBT is 1 upon T flip-flop. Okay, and that is 1 upon flip-flop delay is 8 nanoseconds. Answer megahertz mein hai, to again break it into 10 power 3 into 10 power 6 divided by 8. 1000 is divided by 8 should be equal to 125 megahertz. Do we have any such option? So here the ambiguity stops. Looking into the question, ambiguity is there, okay, but there isn't any option that is 125 megahertz. So if I take it as ripple, counter, so what is going to be the maximum clock frequency? 1 upon TPD. Okay, but TPD for a ripple counter is n times TFF, as I just explained you. 1 upon n. N is how much? 3. Right. 1 upon 3. into 8 nanoseconds. So whatever is the answer, it is going to be 1/3 of this. Whatever is the answer, it is going to be 1/3 of this. Be very clear, because rest all the calculation is same. Okay, so if you take 1/3 of this, how much it is going to be? Arey, ye bhi option nahi hai kya? Then they have done some complete blunder in the question, because if you divide this by 3, it is 40 around something. No. हाँ math आता है. For double E math also comes. We'll take a session for maths also, Diksha. No guys, the calculations are not matching at all. 125 if I divide by 8, then 15.625, then it should be a 8-bit counter, not a mod 8. Okay, no. So this question is 100% wrong given by Isro. 100% wrong, because if you divide this, how much it is? So let me write down this answer first of all. It is 41. Correct, this is 41.67 megahertz. Right, because it is mod 8, it is 3-bit. What they have now taken is, okay, as per mod 8, there is no other option. Okay, but if you take 8-bit rather than mod 8, if they want to specify 8 bits, okay, if they take it as 8-bit, okay, then you can calculate this answer as 1/8 into 8 nanoseconds. 1/8 into 8 nanoseconds. That means the previous answer divided by 8, and when you divide this by 8, then you get the answer 15.625 megahertz. That is the condition. But actually they have clearly mentioned mod 8. Okay. For a mod 8 counter, we don't need 8 bits. Huh? Okay, we don't need 8 bits. So no. None of the option actually matches here as per the given data. None of the option matches here as per the given data. ठीक है. Mod 8 ring counter होता तो ये होता, but they haven't specified. And for ring counter can be made using JK flip-flop also, but that doesn't make any sense. So normally mod 8 means we'll take a 3 flip-flop case. So the question is again ambiguous, and as per mod 8, if I take 3 bits, there is no option matching. If you take 8 bits itself, then 15.625. Okay, then 15.625 only is the option that can match. Okay. But yeah, just sometimes these questions are also telling you that sometimes not majority, but you can say 1 out of 20 times also be ready, you know, that there can be some ambiguous or some error in the questions in Isro. Okay, so guys, Sunday, as you know, okay, you keep getting the coffee with concept sessions, okay, you know, twice a week. So this Sunday it is my turn for coffee with concept, and coffee with concepts are small videos like say 15-20 minutes recorded, not live. Okay, so that in very small amount of time, live mein zyada time lagta hamesha, but in recording in very small amount of time we can explain you a particular concept. So binomial distribution, an important topic for any competitive exam from the engineering maths, be it GATE, be it engineering services, be it Isro, be it NIELIT, everywhere the important topic. Okay, so in a small 15-20 minutes video you get the complete concept and crisp of binomial distribution. You can watch it on the Sunday, and as I also told you, Sunday this session is live now. Okay, this is a guidance, a strategy session, right? Single digit rank, dream of all the aspirants. But what it takes to have a single digit rank, like 1 to 9, what are those 5 success mantras, 1 2 3 4 5, that can lead you towards the victory? Okay, join me for a live session, strategy session, this time Sunday morning 11 a.m. Sunday morning 11 a.m. Okay guys, Sunday morning 11 a.m. Done hai. Chalo guys, that is what, these are the different things going on. GATE 2024 fundamentals की अगर बात करें, right, fundamentals की बात करें तो 9 p.m. tonight in the fundamentals only, 9 p.m. tonight. Okay, there is a session that is going to be questions practice of Laplace transform. Questions practice of the Laplace transform. Question practice of the Laplace transform. Okay. Yeah, Telegram. I'll share you Telegram link, and I'll also share you the link of this particular video in the Telegram. Sorry, the PDF of this session, whatever question and answer we have discussed, but let me make it password protected. The PDFs for my side are always password protected, so that whoever watches the session, maybe now, maybe later on, anyone watching the session will get this password, that is Digi, D-I-G-I, randomly created, D-I-G-I. Okay, you will get the PDF in my Telegram, and that PDF will be password protected. Okay, I'll share the PDF by tonight or tomorrow early morning, and the password will be DG. So these are the different series running up, and the BYJU'S exam prep student success saga continues with 13 ranks under 10, 107 ranks under 100, and 62 ranks under 50 in the recent GATE 2023 results. Okay guys, that's it from my side. So my Telegram link I shall share you once. Just a moment, I'll share you my Telegram link once. Okay, those who are not connected, they can connect me in the Telegram. You will get all other session updates, you will get the PDFs and all important notices there in that particular Telegram group. Just a moment. Yeah, here it is, the link of the Telegram. You can join using the link that is provided. Bye bye, see you in another session. Thank you, stay safe and take care of yourself.